Alright, so here we have the Heatwing T1 Ranger. We're just gonna take a quick look at it, just kind of an overview, and then we're going to maiden it at the end of this video. So I'm not gonna do well, obviously we're not gonna do a build video, it's already built, but we're just gonna kind of show you some of the little changes I made that are unique to this one, or maybe not unique to this one, but differ from a box stock plug and play build basically. So this one is the plug and play, so the motors and ESCs and servos were all included, as well as the props. Pretty easy kit to build, went pretty quick. I'm really impressed with the quality as far as like the quality of foam material. This is the dense gray one. I believe the white ones are the same density as this now. They were originally offered in two different kind of formulas, I guess, for the foam, but I'm really impressed with how nice this foam feels and the quality of the molding and the fit of all the parts, including all of the injection molded parts like the plastic motor mounts and like these wingtip lights and what else? Some of the parts in the tail back there. I think that's pretty much it. You do have these connectors for the wings that just kind of plug in and carries power and control out to the servos and motor and the ESCs. So one thing I did different, well, it's not necessarily different, it's an optional part, but I do have the carbon fiber boom here. It comes with an aluminum tail boom, which is probably fine. I saw this was in stock at Race Day Quads while I was ordering some parts, so I just grabbed it. It was a few bucks. I like it, just the woven carbon fiber like that. The control cable out to the servo. See, the servo is kind of buried down in the horizontal stabilizer, and it kind of pokes out from under the rudder there and works the elevator. So it's pretty neat setup. I really like that. For as small as it is, they did a good job of burying that in there and hiding it. And the wiring does run back through the tail, comes out inside the fuselage. And the entire tail assembly just kind of plugs in and tightens down with this little aluminum nut. So it's pretty neat setup. So I guess we'll just go ahead and move forward from here. You can see I have a Crossfire Immortal T antenna. It's just kind of glued to the side of the fuselage right there. And the cable does run back into the internal compartment, which we'll take a look at in a minute. This little bay here, this little cover is glued in. Normally it has a few fins along the back there, but you can see I have removed those, and I've also kind of hogged out some of the foam right in there. It's kind of hard to see in the dark, but it basically allows more airflow because I'm using that for my air exit and for the air intake. This is the newer version that does have two slots next to where the camera would go. The camera normally goes in here, but obviously you can see I have mine on a pan up here. Now there is an included little foam plug to plug this camera hole if you're not going to use the camera there, but I decided to leave it open for an air intake because normally you have an air intake up here on the top, which I have filled up with my camera and a pan servo, and I just kind of 3D printed that little cover that snaps in place to cover everything and keep it neat and clean. And so yeah, these are my air intakes now. So I have air intakes here and an air exit back there that we looked at. And my video transmitter is actually behind this little camera mount down underneath the pan servo. It's inside the fuselage. And it has a heatsink on it that's directly in this airflow where the airflow comes in. So it's kind of difficult to see in there, but it's in there. And it's sitting right in the air intake that comes into the fuselage. And I have a little cable run up to mount my video antenna there. I'm using this little Menace RC. It's kind of a pagoda style. I forget the actual name, what they market it as, but it's basically a pagoda with a plastic cover on it. I heard good things about it. Some people like it, people that I trust. So I gave it a try. It's a nice little short compact package and it works well there. And seems to perform well for me. So I have no complaints there. You can see obviously we have the Runcam Thumb Pro. I just picked this up recently. I'd asked Banggood if I could review one, if they would provide one for review, and they said yeah, they agreed. They were going to send it as soon as they came back in stock. But I noticed these were in stock here in the US. I think I got this one from Defiance RC if I remember right. And it came into stock before Banggood actually got them, so I just went ahead and bought it with my own money and didn't have to wait on it like that. So this little printed TPU mount, the whole little assembly here is included with the camera. I just kind of mounted it with 3 of the screws that were included. It's just kind of bolted through the foam with nuts on the inside. I had actually clamped it onto, you know, the top half of the TPU mount here. It kind of hinges like a GoPro style right down there. You can kind of make that out. But it's a little smaller than a GoPro mounts. But this top piece actually kind of, it'll slip down over this little finger grip here for this, for removing the canopy. And it's actually your center of gravity right here also. But it'll actually slip over this and pinch down with a bolt and tighten up nicely, but this little piece of plastic is so flimsy, I felt like it was probably going to introduce some kind of shakiness and jello in the video. But I was going to try it anyway and probably end up moving it later, but before I even flew the airplane, I bumped the camera just fooling with it, getting it in and out the mount, and I actually broke this little piece of plastic down here. You can see there's a bit of glue on it right there. I had to glue it back on, so I decided to go ahead and just mount this little base that was included with the camera, just for a little bit more rigid mount, and I don't know, so I didn't break that again, pretty much. So that's about all there is to see on the outside. We'll take a look inside. We'll just pop this off, because the power, because this little camera doesn't have an internal battery. It needs 5 volts plugged in back here to run. So my power lead is unplugged right now, but I'm just going to sit that over on the side out of the way. And taking a look inside, you can see, now you can kind of see that video transmitter I was talking about is sitting right in there. That's an Eachine TX805S, if I remember right. I might be wrong on that part number, but it's the high power Eachine offering. And I used it because I had it. It's the only reason. I really didn't expect much from it. But once I flew it, it seems to be fine. I actually bought a Rush FPV tank Solo, or Solo tank, whatever it's called, from Rush FPV, with the intention of replacing this one with that. But I mean, I'm not going to replace it unless it gives me any problem, and so far it seems to work fine. So maybe we'll save the other one for a future build. For the battery, I'm running a 3S18650 lithium ion. That's from AU line, and you can see I have it just kind of sitting right in there. I'm using the included little Velcro strap. Now there is just a little simple wood plate with slots for this to go through that gets screwed down. You see you have these 2 plywood rails that run down inside the fuselage there with different mounting holes so that you can slide parts front and back and just screw them down where you need them. But I actually 3D printed battery tray right down there. You can see the screws that holds it in. And I'm not sure how well you can make that out. Maybe if we lean it up, get more light. Yeah, you can see there's actually a little plastic wall on each end of it that keeps the battery in place. So there's a little wall on the back of the battery there and one in the front of the battery. And then the strap just holds the battery down to the tray in between those 2 walls, so it can't slide front or back. Makes a nice little neat compact setup that's quick and easy to use. And it works. So moving back from there, you can see that's the front end of the flight controller. It's a Matek F405WSE, if I remember right. And this is the little remote board for it with the USB port and status LEDs and the buzzer. If we lift the back part of the hatch here, you can see that's actually mounted to a little 3D printed tray that rides on the spar where it runs through here. The spar just kind of slips through and holds it, and the back just kind of gets nested down in here, and the back cover holds it down. And that little tray holds that little remote board for the flight controller as well as the GPS. And you see, you just, once the cover's removed, you can just kind of flip it up and get to the top of the flight controller if you should need to access the SD card or anything like that. And that's also where all my wires are kind of nested back here. And this is that 5 volt power lead that I was mentioning for the Thumb Pro. When I use it, it just kind of gets tucked, comes out between the 2 halves of the top hatch there, and makes a nice little clean setup, plugs into the camera. And there's my receiver. It's just the TBS Crossfire. It's just kind of hanging on the cables. The cables and the coax for the antenna is stiff enough. It just kind of rides in there. This is one of the Nano RX Pro that will do up to 500 milliwatts output for the telemetry. And I went with that one because I wanted to have a full telemetry link back to Mission Planner while I'm flying, and I thought the higher output would probably help with that. And I'm pretty sure it will. But the issue I ran into is you have, I think there's minimum, middle, and maximum output power for the receiver for telemetry output. And I had to leave it on minimum, which is 25 milliwatts. Middle is 100 milliwatts, and maximum is 500 milliwatts. If I raised it to minimum, I started to see a little bit of jittering in my pan servo. The other servos in the airplane seemed fine, but my pan servo would start to kind of twitch around a little bit. And if I put it on high output, on the maximum output of 500 milliwatts, the pan servo pretty much went crazy. It just kind of started jittering all over the place. Now, I don't know if that's from the receiver itself or from the antenna. I'm assuming it's 900 megahertz noise from the antenna. But the servo cable runs from the front right to the front of the flight controller. It lays down under the battery tray. It doesn't go anywhere near the back. So there's not really much else I can do for separation other than maybe move the antenna and the receiver out on the tail somewhere. But I just ended up leaving it on 25 milliwatts. Now, in theory, everything should work. What I'm doing, I'm only using one UART between the flight controller and the receiver. And I have that set up for Mavlink version 2. So I'm running ArduPilot on flight controller. And I'm using Mavlink between the receiver and the flight controller. And in the receiver settings in the TBS Agent Lite on my radio, or you can do it on the software on the PC as well. But in the receiver settings, I enabled Mavlink, RC over Mavlink. So this Mavlink is my telemetry from the flight controller back to the receiver, as well as my RC signal from the receiver back to the flight controller. Now, the RC signal and the RC control never gave me any trouble. It was 100% perfect, zero issues there. And on the bench, I can connect wirelessly from the TBS to Mission Planner through the TBS transmitter, the Crossfire transmitter. I have the full-size transmitter Lite that doesn't have Bluetooth, but it does have Wi-Fi. And I have the Wi-Fi updated to the latest 2.04 firmware, I believe it is. And I have it set up, it's connecting to the router in my shed to my home network, which allows it to push Mavlink out via UDP across my network. And in my PC running Mission Planner or whatever other ground control station software that I want to use can connect to it that way. And it works pretty good on the bench. I've never really had any trouble with it. It's a little bit slow, but it gets the job done. I can get all the parameters downloaded. I can change things, set things up as if I had a USB cable connected to the flight controller. And in theory, that should work in the air as well. It's what I do with my Dragon Link setups with all my other Arduplane builds. And it's always worked flawlessly there. But with this one, just as pretty much everyone else that I've found that's tried this setup with Crossfire, just as they all report, it works fine on the bench, but when you get in the air, telemetry is very unstable and unreliable, and any kind of distance, it drops the connection completely. And that's pretty much exactly what I saw. Once I got any kind of distance, like half mile out or so, it lost the connection, and it wouldn't regain it until I was flying overhead for quite some time, like loitering overhead. I saw the connection come back a couple of times, but it quickly loses it again. It's not really usable. It's not something I'm going to rely on. I think I'm actually going to switch this back over to Crossfire protocol between the receiver and the flight controller, which will do the same thing, telemetry and the RC signal, but it's in the little bit more robust telemetry back to the radio, like kind of the same setup I do with my iNav stuff. I just think that Mavlink implementation on the Crossfire system still has a lot of bugs to be worked out. Has a lot further to go before it's usable, in my opinion, other than maybe for configuring stuff on the ground. But as far as a good stable link in the air, I'm not going to bother with it any more than I already have. That's pretty much it. About the only other thing I can mention is right down here. If you can really look close, you can make it out down there. Try to get some more light in there. You can kind of see it. Yeah, you can see the front edge of the board right there. That is the LED controller from Heewing, which that actually wasn't included with this kit. It's something they recently came out with. I'm not sure if they're going to include them with the kits later. It would be nice if they did. But I actually reached out to them and asked about the LED controller because I couldn't find it in stock anywhere in the US at the time. And they were nice enough to ship me one free of charge. They put it in the mail. I had it in about a week and a half. And actually by the time I received it, I saw Race Day Quads actually has them in stock now. So if you're looking for one, I'll have a link to that down below too. But basically it allows you to control the wingtip LEDs. You have one out here and one in this wingtip. And they get connected through some of the connectors there when you plug the wings in. And by default, those LEDs come wired together, so they're addressable LEDs, but the problem is the way they're wired out of the box. They're just wired in parallel, so they're both the first LED in the chain, which means that like iNav is really easy to set up addressable LEDs, but if you plug them into the LED pin and try to set them up, they're both going to always blink the same pattern, be the same color. They're just two of the same LED basically. You can only control it one way. You can't control them independently unless you can add another LED in line. You can kind of cut the wire and solder another one in line so that the one in the wingtip becomes the second wing. You do that on one side, and then you just have like a sacrificial LED that rides inside the fuselage, and it makes that wingtip the second LED in line, so you can set them up different. But this is a lot easier. Just kind of clip the connector off, solder the wires to this little control board, then you just have little push buttons to control it, which worked out well for me anyway because ArduPilot's implementation of addressable LEDs is still not very user friendly. It works. But if you want to have like custom patterns and make nav lights or anything like that, you have to do it with Lua scripting, which by default doesn't run on the F4 base flight controllers, at least this one, because of limited memory. It's one of the features that they removed to make it fit on the F4 boards. So it was just a lot simpler to run this standalone on the side. It needs 5 volts, push a couple of buttons. You can control the two LEDs independently. You can control the colors independently, I should point that out. You can set the color of each individual LED, but then you have a third button that changes the blink patterns, and they both blink the same pattern. But these are not blinking anyway. I just set them up. They're solid LEDs. I have one green, one red, just wingtip like nav lights, and they're solid the way nav lights should be. And then there's actually 2 LEDs. There's one on each ESC in the little motor nacelles. If you can make that out in there, maybe you can, maybe you can't. If my camera would focus. Not sure if we're going to be able to see it through the slot, but yeah, there it is right there. You can kind of see it. But there's a little LED on each of the speed controllers, which again, I think that's only in the newer kits. It wasn't in the early builds. They kind of switched up to the different ESCs. But by default, they come disabled. And you have to download a BL Heli Suite, and you can connect to the ESCs. I just use pass-through, the pass-through mode, just to talk to it through the flight controller, and it worked fine. And I was able to configure the ESCs. I went ahead and made sure the brake was on, and the motor directions were right, and I enabled those LEDs. So I have the 2 white LEDs in here, which are kind of, I'm calling them landing lights, but they're not really landing lights. It's just there's 2 white LEDs in the center and then the 2 wingtips, or my nav lights. So I'll actually put up a picture of that here. I'll take a picture in the dark where you can kind of see what it looks like. But yeah, I'm pretty sure we covered everything as far as the build and the way I set it up and what I did and what I didn't do. Only thing other thing I haven't really talked about much is the pan servo. It is a standard old Hextronics 5 gram. It's, what are they, the HXT 500s, I think, the old 5 gram Hextronics servos. Totally stock, not modified, just plugged into an extra servo output on the flight controller. And I set it up in ArduPilot as my as a servo gimbal. as the pan servo for a servo gimbal. And what that does is allows me to extend the output from the standard 1000 to 2000 microseconds. I've actually extended it from 500 to 2500 microseconds, and that gives me 180 degrees output with a stock servo without having to modify it. And we actually did forget to mention the camera. If I can pan it over here, you can see it's the Caddx FPV, the Baby Ratel 2. If it will focus. Come on, camera. My camera doesn't want to cooperate today. Come on. And there we go, you can see it. It's a Caddx FPV Baby Ratel 2. Stock camera, nothing special. The only thing I did out of the box was switch it from PAL to NTSC mode, and that's it. Haven't touched the settings in it, and everything seems to work fine. So I don't think I forgot anything, but if I did, if you have any questions, drop them below the video and I'll try to answer them. But we're going to get on to the maiden flight now. We're going to go ahead and make this a long video. Alright, so we're flying. It's the maiden of the T1 Ranger. And so far everything seems to be working fine. Other than the map's not loading in Mission Planner, which I'm not too sure what that's about, but I'll look into that in just a second. Probably an internet issue on the computer. Let me see if I can cycle my internet connection. Yeah, that did it. Alright, so we're in the air. Everything seems to be working. I do think my current reading is wrong. For some reason, it's bouncing around quite a bit. And the efficiency numbers are all over the place. The battery voltage is flashing. It is going to sag a little bit, as to be expected. It is a 3S lithium ion battery. But other than that, everything feels good. That pan seems to work well enough. Look out over this wing as well. So I guess we'll go ahead and gain some altitude. Just gonna go ahead and climb up a bit, and we'll fly out over this area and do an auto tune. See how that goes. I guess we're gonna get up around 300 or so feet. Alright. Now let's go to, this should be auto tune.
Auto.
Alright, we started an auto tune, so let's start doing the roll axis. It actually started out really sensitive and now it's getting really sluggish. I do have the auto tune. There was a little bit of wobble there. So we're getting some values popping up now. There's the D value that it has arrived at for the roll axis. I noticed a little bit of wobble there. There's a P value. And roll finished. Alright, so let's aim back towards home and we'll start doing the pitch. So what I was saying previously though is that I do have the auto-tune level set to default of, I think it's 6 is what the default is. Whatever the default is, that's what I have it on. So that's what it's going to tune for. So it shouldn't be too agile or responsive. Notice a lot of wobble there. Okay, there's a D value for pitch. And we're waiting for the P value to come up next. It should start to kind of wobble a little bit in the pitch axis. There it is. And there's our P value. And we'll keep banging the sticks a few more times and we should see P finished. There we go. So now we can go back to fly-by-wire A. And let's just see how this feels in fly-by-wire for a minute and then we'll go back to cruise. So yeah, it's a little bit less responsive now after the auto-tune, and that is because of the auto-tune level. It was a little bit more responsive by default. And I do have the control horns, the linkages, one hold in on the servo arms from all the way out, because I did kind of expect them to be a little bit sensitive, the controls. But seems to be fine as it is. Alright, so let's go ahead and go back to cruise. And we'll let everything fly in cruise for a minute just to let it trim itself. Now I do notice my telemetry has stopped working in Mission Planner, and that's kind of what I was expecting from Crossfire based on what I've seen from the other people that have been using it for a full transparent link to Crossfire. So I'm not doing the Mavlink emulation. I'm actually doing a full transparent link through the Crossfire's Wi-Fi through my home network via UDP, which is the same way I do it with Dragon Link. But it worked fine on the bench, but just like a lot of other people have reported, as soon as you start getting a little bit of distance, it'll just kind of stop working. So I guess that's where we're at with that, and we may investigate that later, but I did want to try it at least once just to see if it worked, and it did to an extent, which is pretty much what I expected. Seems like a nice flying little airplane though. I do think I need to figure out why I don't have a stable amp draw current reading. And I also would like to figure out why my airspeed is not showing on the OSD. Because I thought I had it set up to show the synthetic airspeed there, but maybe it's not. I need to look into that. Because I don't have an airspeed sensor on here, but it is indicating wind speed on the OSD, which I thought it calculated from the synthetic airspeed. So maybe I just have the airspeed item on the OSD configured wrong. I'll need to look into that. Make sure I have the right one selected and all that good stuff. But yeah, it's holding altitude and flying well. It is getting rocked around a little bit. Right now it is a little bit bumpy out. The wind's kind of been coming and going all day, pretty much. It's not terrible, but seems well enough, seems fine. So let's go ahead and do a return to launch.
Return to launch.
Which is going to gain altitude, and it's going to go around a rally point. Which, let me see if it's still showing. Yes, I can show you that. If I hide the video here, you can see I have a rally point right there in the center of the map, which is just south of the runway, which you can see we're coming up on now. So we should loiter that rally point rather than the point where I armed. So that seems to be working as expected. I really wish my telemetry would work, because I kind of miss having that, but I guess we'll try to look into that later. Yeah, it's loitering that position really well, holding altitude. Working really nice, and I haven't tuned any of the TECS parameters or done any final adjustments after the auto tune. It's just, I mean, you've basically seen my maiden. You've seen the extent of it from start to finish here. But so far I have no complaints. Pretty happy with it. The way the airplane feels, the way ArduPilot is flying it. I like the video system, which is kind of surprising, as I really didn't expect much from this video transmitter. This is not the Rush Tank Solo, by the way.
Fly-by-wire A.
Oh, we just picked up telemetry once again. If I show you that screen, you can see it just picked up telemetry, and everything's updating again. So it did start working for some reason. Could make a loop back towards home. And see, so maybe it's something to do with that 150 hertz mode that it gets locked into. It's still not updating very fast, but it is updating, which is, I guess, something better than nothing. But yeah, I'm not real impressed with the performance of the Crossfire telemetry link, but I guess we'll take what we can get from it for now till it improves, if it ever does.
Lost.
And we just lost a sensor apparently in the telemetry, but everything's still updating in Mission Planner. I don't know, it's kind of hard to figure out what's going on with it. So yeah, like I said, it's a 3S lithium ion battery, so it should be safe up to around what's that, about 3 volts per cell is about as far as I want to push it, so we can push it down to about 9 volts. I'm just kind of watching my voltage, because I'm not really going to rely on that milliamp hour counter or the current sensor. I don't think that's accurate, but maybe it is, who knows. I'll have to put my power meter on it and see what it's actually pulling at about 52% throttle that we're flying at right now. So about half throttle, and I noticed we are losing altitude a bit in fly-by-wire A, so I'll need to change the parameter to tell it how many degrees up it needs to fly straight and level. But for now, we'll just fly in cruise, so that it'll maintain altitude for us. And we'll go from there, but so far everything seems to be fine. Fly out here where we can see the cows. And of course we do have the Runcam Thumb Pro 4K. I'll probably edit that video and put it in a separate one from this one, just because I'm not sure how I'll edit it into this, and don't really want to deal with kind of sync everything up just yet. There's another vehicle on the road below. Get a nice look at it. But yeah, all that green field straight ahead right there is tall sugarcane, so I don't want to fly back out that direction too much just yet. Still having flashbacks of trying to find the last airplane that I made out in the tall bean field south of here, so it's kind of why I've been keeping this one out over the cow pasture and this other field back this way, That brown field ahead is where they've recently cut the corn, so it would be easy to find an airplane out there. But it's trying to mitigate the risk, or minimize the risk rather. And you notice I'm playing with the power on my video transmitter there. Is using smart audio. That is working. That's another thing I've tried for the first time in RG-Plane. I cut power all the way down. You see the audio gets kind of staticky and the video grainy. But if we turn it up even to the second power level, it works a little better. There's the third power level. There's 4 levels. They read 25, 200, 500, and 800 in the OSD, but they're actually 25, 500, 1 watt, and 1.6 watts. It's the Eachine TX805S video transmitter, but I never found a way to change the values that it actually reads in the OSD. So I guess it just kind of corresponds with the levels 1, 2, 3, and 4, and those values are just hard-coded, predetermined. But like I said, it works. So yeah, I guess that's about as much as we're gonna do with the Maiden right now. I'm just gonna land it, and we'll go back over some logs and look at some things to improve on, and go from there. See where we end up. The most glaring issue I see right now is that weird current sensor thing that I don't like. So we're going to go ahead and switch back to fly-by-wire A.
Fly-by-wire A.
I'm actually going to point it out back over the cornfield once again, or what was a cornfield anyway. And I'm going to switch to manual. I just want to make sure everything's trimmed.
Manual.
Yeah, not a single bit of trim needed. It is really touchy in manual mode though, which is kind of to be expected even with the reduced control throws.
Fly-by-wire A. Cruise.
Based on what people were reporting. So those could possibly be reduced a bit, but it flies fine. I'll probably just leave it alone. So I actually do have
Manual. Low rates.
triple rate set up. On low rates, it actually feels quite good on manual. Yeah, that's fine. I can just fly it like that. If I ever need to fly it in manual mode, I can just drop the rates there. So let's go back to fly-by-wire A.
High rates.
And go back to my full rates for fly-by-wire. And we'll go ahead and get over this way and set up my approach for landing. Look over the wingtip, make sure we're not too close to the bayou and the trees out there. We'll start cutting power. Push the nose down, lose some altitude. And I don't know what power level or airspeed this thing stalls at just yet, so we're going to carry a little bit of power through the landing. We'll go ahead and cut power now, start a glide and a flare. Nice smooth landing, I'll take it. So that's been the Maiden of the Hewing T1 Ranger. Looks like we might have picked up telemetry once again. Yeah, I'm not real impressed with the telemetry performance for the telemetry link anyway, using Crossfire Wi-Fi setup. Go ahead and cut the power down on video transmitter so we don't overheat it. And yeah, I guess that'll be the end of this video, and we'll have some more to come in the future, so stay tuned for that. Thank you for watching this one. I'll see you all in the next ones.